So in this question, I'm told that the graphs of y against x represent 4 different types of proportionality, and I'm asked to match each type of proportionality in the table to the correct graph. So if I have a look at the table here, in this column I have the types of proportionality, and this symbol here simply means is proportional to, and then I need to fill in this column of the table with the letters corresponding to the graphs above. So if I just take a moment to make sense of the graphs that we've got to start with, we've got graph A, which is kind of a decreasing curve here, a smooth curve, but it's decreasing, the gradient's decreasing. For graph B, we have a straight line graph here. Graph C, we have another curve, however this time it's not starting through the origin. That's an important thing to note here. It doesn't go through the origin. And these points of the graph tend to the y-axis and tend to the x-axis. They never reach them in this diagram. And then we have graph D. Similarly, the gradient of graph D is increasing, and we have a smooth curve here also. So now if I have a look at my types of proportionality, firstly here I have y is proportional to x. Now if y is proportional to x, this is a form of direct proportion. So they're in proportion. If one increases, the other increases proportionally. So if y is doubled, x is also doubled. So I could write this out slightly differently. I could take y being equal to some constant of proportionality, so k, some value k, multiplied by x is how I could write y is proportional to x. We don't need to know what k is, but I can see here that this form of the graph y is equal to something multiplied by x is going to be the form of a straight line graph. So similarly to y equals mx plus c. We don't have a c here because the y-intercept's 0. However, we do have this k, which kind of represents the gradient in this case. So this is going to give us y being directly proportional to x is this straight line graph. So graph B is going to be the correct answer for this one. And similarly here, for y is proportional to x squared, I can use the concept of this constant of proportionality again. So y is going to be equal to k lots of x squared. Shows that y is proportional to x squared. Now, as for what this will look like on a graph, we have some value of k, so a constant, a rate constant, and we have y is equal to k lots of x squared. Now we've got this squared term, this squared value for x, so instantly here I'm realising that we're working with a quadratic. Now this is going to be a positive quadratic because k is going to be a positive constant in this case. X squared is always going to be positive, so it's always going to be increasing. So we can have a look at the graphs, and here I can see graph D. We have basically the part of a quadratic, a part of a simple quadratic, where we have y increasing at a faster rate than x. And that makes sense because if we're squaring x, and y is proportional to the square of x, y is going to be increasing faster than x, and we have this smooth curve here, so I can write down the answer of graph D for this one. And now here I would probably jump across to the last one in this column, just because it's probably easier to notice as we do see this graph come up quite a lot. And this is y is proportional to 1 over x. Now another way of saying this is that y is inversely proportional to x. So if one quantity increases, the other is going to be decreasing proportionally to this. So if y is doubled, x is going to be halved. So similarly here, I may already know the graph and I may realise that this is going to be graph C. This shows an inversely proportional relationship. However, if I didn't know that, I could have a look and I can see that the graph doesn't cross the x or y axis, it only tends to them. Now this makes sense because if x were to be 0, there are going to be no real solutions for a value of y, because 1 divided by 0 is going to give us a maths error. We can't calculate that value, so there's no solutions for y. So the other graph that we have left is graph A, and we have that when x is 0, y is also 0, and this definitely can't be the case because we cannot divide 1 by 0. So I can then fill in this as graph C, and then that leaves me with y is proportional to root x being graph A here, which we could see if we were to square both sides. So we had y squared is proportional to x. It's kind of the opposite of y is proportional to x squared. And this time we have a decreasing curve instead of this increasing curve that we had here. And that makes sense if we just look at the other graphs and work with the values that we're given. We could always substitute some values in if you weren't too sure on what would happen. Substitute some x and y values in and just get a rough idea of what happens with these graphs and to see the shape of the curve that it may create. So as for how the marks are awarded, we would get the first mark for getting 2 of the answers correct, and then the second mark would be for having all 4 of the answers correct here. And that brings us to the end of this question.